It's tough out there for a spacecraft. Hardware in space must brave an ocean of dangerous radiated particles. These particles can slowly wear on a spacecraft over time, hit once and cause a temporary problem, or short the system in a single blow. Whether a spacecraft is heading to the moon, like the Artemis mission, or facing off with the sun, like Parker's solar probe, everything on board must be checked for reliability before launch.
Every part has to be tested, and that's where our group comes in. We take the models and we figure out what the radiation environment looks like, and then we test based on that environment and figure out whether the part will survive or not.
To improve our spacecraft and protect our hardware as it travels through space, NASA has the Space Environment Testbed mission, or SET.
This is a mission where the whole point is radiation.
SET helps researchers to better understand and design for the potential radiation effects that await spacecraft.
It's actually doing measurements of the radiation environment. Some measurements are actually counting individual particles as they come in, and other measurements are actually taking account of what the cumulative effect of all these particles are.
All of space is a radiation environment, but the exact conditions will vary by destination. The Sun fires protons. Earth harbors swarms of protons and electrons. Jupiter does the same, but in greater concentration and at higher energy. And everywhere you go, there are heavier ions from galactic cosmic rays. No spacecraft passes through unaffected. More knowledge from SET means more efficient spacecraft designs. For example, less shielding may be necessary.
Right now we assume that all missions are going to have a shielding thickness, and so by shielding thickness we mean how thick are the walls of the spacecraft or the instrument. And we assume they're going to be about 1/10 of an inch. If we can get better models and we can more tightly refine what the radiation environment looks like, we can maybe thin those walls out.
Lighter, thinner spacecraft can create savings in cost and room on board.
We always need to improve our designs of spacecraft because it will help us improve our instrumentation, make them less expensive to design, and give us more accurate measurements.
We also expect there to be applications to help protect the hardware that will bring people to the moon and beyond.
We'll be able to ensure that humans and electronics and spacecraft and instruments, anything that we're actually sending into space will survive in the environment we're putting it in.
With SET, NASA can get ready to go farther.